Good morning to everyone. I'm Giovanni Dalmaso, and here there is my dear colleague Chiara Peccerillo, and we are first year PhD student in applied entomology. So we work with other staff, with control of pests and other. But thanks to Valerio Mazzoni, we get involved in biotremology and communication. And so today we are going to talk a bit about this side project of hoppers in the Apple Agroecosystems. So we know that there are plenty of Auchenorrhyncha species that live in apple trees, but we selected three main species. Why these three species? Because two of them are alien species, one from the US, Acanalonia conica, and another Orientus ishidae from Asia. And all these three species, and Agalmatium flavescens is a native European species. All these three are possible new pests for apple proliferation, for apple agroecosystem. Two of them can be a vector of apple proliferation, that is a disease, phytoplasma disease of apple, very important in North Europe. And Acanalonia conica can make a lot of damage in the plants, the leaf and other parts. So we take these three species, even because the number of all these hopper are increasing in the last few years, with thousands of Orientus, for example, in the orchards. And we know that all these three species can communicate with vibrational communication, and they are very difficult sometimes to monitor. So to know the number, the population level, we usually use frappage methods or yellow sticky traps, but not for all these species are very effective, these methods. So for example, Orientus is attracted by yellow sticky traps, but Agalmatium flavescens can't fly, so it's not a really good system to monitor. But all these three species use vibration, are leafhopper, and so they use. And then we find all these three species living together in the apple. So even in the same leaf, we can find all the three species. And we ask themselves what kind of interaction they could appear between all of these three leafhopper. And we maybe in the future exploit this interaction. But to know if we can answer this question, we want to register to know if and what are the signals they use. So the first objective of this project is to identify the vibrational signals, at least one for each species, and when they are active, so when they are singing more. So this summer, we collect leafhoppers in some apple orchards in Trentino in July. We collect only adults with a lot of methods, frappage or mouth aspirator, and we take them to San Michele in the lab. We put the leafhopper on a cage in semi-field condition, and we record for 24 hours the male for each species, different cages, so in separate population. We record all these the signals with accelerometers. And why we choose only male? Because we think that they are the more active. They sing a lot for calling the female, and so there is a very sure chance that we record our signals. So I give the floor to Chiara, and she show the results.
Thank you, Giovanni. Okay, let's talk about the result. Starting with Acanalonia conica, we observe a signal that is characterized by a series of pulses followed by an harmonic structure that is like this. And then observed the daily period where they are active. We identify a range of activity that starts from late evening and go on until the morning. again. Okay, then there is Orientus ishidae, and we recorded a signal that has been already described in detail by our colleague Juan Lopez Diaz, and it's pretty like this. And yeah. And in contrast with the first insect, we can see that there is no interruption during the day, but he is seeing all day long with the 2 peak of activity during the evening and at the where is the dawn. And then finally we see Agalmatium flavescens. And this is record is quite silent, so we hope to let me. Yeah, actually, this is a regular structure composed by a train of pulses that can last from few seconds up to more than 15 minutes, and we see that his range of activity go. From the late night till the morning, and with another peak on the sunset. So, plotting the result of this daily experiment of each species, we assess that there is 2 times where there is an overlap of the signal, and then there is set in around from 20 to 22 around, and in the sunrise. So let's keep in mind that this experiment is a preliminary experiment that have been carried on with the no disturbs, because every species had recorded by single and single insect. So what can we say about this result? This been explorative experiment, but we start to create a little library and assess the activity period and assume what is the time during the 24 hours where these insects are active simultaneously. But for say it with certain, we have to it's necessary to carry on in the next future behavioral trials for understand better the intraspecific interaction that, for example, could be the competition of signaling space, of the creation of cores, and then all of this will be functional for our last long-term goal. That is field activity with the strategies that has been already mentioned by our colleagues from San Michele. And so this is preliminary results, but we hope to see you again with update result in other occasions. And thank you all for attention. And this is it. Thank you.